All right, let's start this problem off by labeling what we know. So we're told that HM and AT are congruent, those two lines there, and that HT and AM are congruent. We also know that HE and MEA are perpendicular, and HA and AT are perpendicular as well, so right there. Okay, so what we're trying to prove is that if we were to multiply TA and HA together, we would get the same answer as HE multiplied by TH. All right, so we'll want to start off by creating our good old chart with statements on the left, reasoning on the right. And it's always good to start off with what's given. Now the next thing we're going to want to state is fairly obvious, but it is important to give as a statement with reasoning that the angles HEA and TAH are actually right angles. I mean, we're told that they're perpendicular, but it's always good to explain that that means that they're right angles. But now that we've explained that, we can now give a statement saying that those two angles, HEA and TAH, are congruent. So at this point, I'm going to pause for a second because so far we've pretty much just stated some pretty obvious things. So I'm going to explain what our strategy is here. What we're going to want to do is take a look at these two larger triangles here. This one, HTA, and this triangle HAE. Now, they look like they're the same, but we want to prove that they're actually similar triangles. If we can do that, what we can do is create two proportions that involve those lengths involved in this proof. By creating two proportions, think of that as two equal or equivalent fractions, then we can do some cross multiplication to get to our final proof here. So that's our goal. So moving on to step 4, you can see I've written down a statement that math is a parallelogram, and that's because we have a quadrilateral with two pairs of congruent sides, so therefore this must be a parallelogram. Now the reasoning this is valuable to state is because we can now say that the lines MA and TH are parallel. Now you might be wondering why that's useful, but we'll get to that in a second. So you can see with that statement, the reasoning I gave is that opposite sides of a parallelogram are parallel. I mean, that's why it's called a parallelogram. Okay, so now I'm going to explain why this was useful. Because those two lines are parallel, we can now identify that this blue angle here, which is HAM, or ham, is going to be congruent or the same as this angle here, THA. And that's because we're dealing with alternate interior angles. Now, the reason that was very helpful to us is because we can now state that that purple triangle and this green triangle identified earlier, we can state that they're similar now. And that's because they share the same angles, right? These two blue angles are the same, and they both have a 90-degree angle. So therefore, the last two angles are also going to be the same. So as a reasoning, we'll just write 8a. All right, now we're almost finished. So what we're going to do now that we've proven these are similar triangles is create two equal proportions. Now what we're going to do is I'm going to pick two sides to create a fraction that are opposite in this equation here. For example, I'm going to create a proportion of HA over TH, and then we can make it equal to, well, let's start with that first. So HA over TH, and we're picking those two because HA is the hypotenuse of the green triangle, and TH is the hypotenuse of the purple one. So those are corresponding sides, right? They're going to be in proportion. And the other two we're going to pick are going to be well, let's call them the heights of the triangle. We've got TA and HE, right? So, but because we've chose the green triangle as the numerator of the fraction, we'll do HE as the numerator of the other one. So it's the other proportion is going to be HE over TA. And the reasoning behind that is because corresponding sides of similar triangles are in proportion. Okay, so you can see where we're going with this. Now if we cross multiply, we can state that TA multiplied by HA is going to equal HE multiplied by TH. And for reasoning, I mean, we essentially just did cross multiplication, but the fancy technical way of explaining it is that the product of means equals the product of extremes. All right, and we are all finished. Hope that was helpful, and thanks for visiting JD's Preparation.